Hello students, welcome back to the fifth video of this playlist. So in this video we will be solving question number 5 from May 2024 statistics 1, that is S1 paper. So let's see what's the question number 5 is about. So the concepts behind this question, that is question number 5, is basically from normal distribution. That is basically the last chapter of your statistics S1 textbook. That is chapter number 7, which is the normal distribution. So in order to be able to solve this question, definitely you should know the concepts of that chapter number 7, the normal distribution. You should have clear idea about the normal distribution, how the normal distribution works, and also very important, most importantly, the bell curve. The bell curve is very important, like interpretation of the bell curve. It's very much important from the normal distribution chapter, which will be also useful here. So let's get started with question number 5. Okay, in question number 5 they are saying a competition consists of 2 rounds. Okay, the time in minutes taken by adults to complete round 1 is modeled by a normal distribution with mean 15 minutes and standard deviation 2 minutes. So what they said here, the time, right? The time taken, this is distributed what? This is distributed normally with mean how much? 15 minutes, and standard deviation 2, that is the variance is what? 2 squared, right? That's it. Now part A asks to find that what? Use standardization. We need to use standardization to find the proportion of adults that take less than 18 minutes to complete round 1. So we need to find out the probability of T what? Less than 18. Correct? Yes, less than 18. So it can be written as, like, we have to standardize. So in that case, probability of Z is the standard value, less than or equal 18 minus what? The mean, 18 minus 15 over the standard deviation, that is 2. Fine. So this is basically probability of Z less than or equal 3 over 2. So let's find out this value. How can you find this out? You can check it out from the formula booklet, but let me show you using the formula booklet, since calculator might not be available to you every time. So you can use your calculator. Yeah, you can use your calculator if you have FX991EX, class-wise or even non-class-wise. You can use to find out the probability, or you can use this distribution table, right? So we need Z less than or equal 1.5. It's available there. This is 0.8749. okay, or you can use your calculator. If you have class-wise, then go to mode on your calculator and then go to mode and then press 7. Then you will have options like normal PD, this is normal probability distribution, then normal CD, this is normal cumulative distribution. So we need cumulative, so press 2, and then lower limit would be negative infinity. Put negative infinity, I mean negative 9999, something like that. And upper limit would be what? Since we are finding less than, so upper limit is what? Here it is 1.5, right? Yes, so the probability will get, it's what? 0.933. okay, it's 1. It's 1.5. so 1.5 is where? 1.5 is there. 0.9332, that's what I got exactly in my calculator. 0.93319, so 0.9332. okay. Okay, so we got the value, that is how much? the probability is 0.9332. Okay, fine. So the probability is 0.9332, which can be written to 3 significant figures, 933. Okay, so this is up to 3 significant figures. Okay, next, for part B, they are saying only the fastest 60%, only the fastest 60% of adults from round 1 take part in round 2. Okay, so only 60%, the fastest 60% can get into the round 2. So part B asks to use standardization to find the longest time that an adult can take to complete round 1 if they are to take part in round 2. That means we need to find out the longest time, okay, the maximum time that they can take to complete round 1 and still they can get into round 2. This is basically what? Consider this as probability of t should be what? Less than, consider this as x, the longest time. It should be how much? It should be fastest 60%, so it should be equals to what? 60%, 0.6. Fine. So probability of z less than or equal x minus 15 over, what was the standard deviation? This is 2, this is equals 0.6. now we need inverse normal, right? So 0.6, which probability corresponds to 0.6? If you have a class Vice calculator, then go to distribution, that is go to mode and then press 7 and then go to inverse normal. Inverse normal area we need 0.6, sigma is 1, mean is 0. Okay, so we'll get the value for the standard value for z. It is x minus 15 over 2 equals to what? They said the fastest 60%. So if you consider the bell curve, okay, so this is basically the mean. So the fastest 60% would be what? This is the mean 0, would be less than that 60%, right? So this will be positive. So this is 0.2533. okay, so what would be the value for x? So the value for x would be 0.2533 times 2 plus 15. This is 15 point what? 15.5. Is it minutes or seconds? It's minutes, right? So this is what? So x equals to 15.5 minutes. That's it. Done. Okay, so if you don't have class Vice calculator, then how can you like get the value for z, the standard value for z? Let me show you using the what? Using the formula booklet. Go to normal distribution and then we need how much area? 0.6, right? So which one corresponds to 0.6? It will be 0.25, right? You can use 0.25. So 0.25 times 2 plus what? 15.5. Same answer. You can consider the closer one, that is 0.25. okay, the one which is the closest. Like here 0.26 is also possible, 0.25 is also possible, but we are considering 0.25 because this probability is more closer to 0.6, right? It is of difference, like from 0.6 it is how much less? it is 0.0013 less, this one, and the next one is basically how much greater? 0.0026 greater. So which one is more closer? Definitely this one. So that's why this one is to be taken. Done. Okay, so let's see the part C. What's the part C is asking there? We are done with part B. For part C, they say the time t minutes taken by adults to complete round 2 is modeled by a normal distribution with mean mu. Okay, so the time t minutes, this is different. Fine, this is different distribution. Different distribution means the variable is different here, t minutes. Though our considered, like previously we considered capital T also, now it has got overlapped, so don't consider the same. The mean for the second round and the standard deviation for the second round is totally different from that of the first round. Okay, so given that probability of t, okay, t greater than mu minus 10 less than mu plus 10 is 0.95. so let me show you using a bell curve. So here the concept of bell curve is very important. Okay, so at first let's draw a bell curve here. Look, so a bell curve looks like this, right? Like this. Okay, this is the mean, isn't it? This is the mean. So here the mean is what? For the standard values, mean is 0. So mean minus 10. Mean minus 10 is basically consider, let's suppose here, and we know that bell curve is what? Symmetrical. So here if it is here, then it will be also there, right? The area would be similar. Okay, so this is mu minus 10 and this is mu plus 10. Okay, now this area, they said this area is how much? This area is 0.95. 0.95. okay, fine. Now next what they have said, we need to find out probability of t greater than mu minus 5 given that t greater than mu minus 10. Okay, probability of t, we need to find out probability of t greater than mu minus 5 given that t what? Less than mu minus 10. Is this what they have asked for? T greater than mu minus 5, t greater than mu minus 10, t greater than mu minus 10. Okay, it should be greater than. Okay, so this is conditional probability, right? That is from chapter 4, the probability chapter, right, from your statistics S1 book. So for conditional probability, the condition will be always in the denominator. So probability of t greater than mu minus 10 would be in the denominator. Okay, and on the numerator, what it would be? It would be the part that falls within the condition. The part that falls within the condition. That means t greater than what? Mu minus 10. Okay, or they said greater than mu minus 5, so it would be just what? Look, let me show you using a number line, not number line, let's consider it on the bell curve. Mu minus 5 is where? Mu minus 5 would be between mu minus 10 and mu, right? So it would be here. This is mu minus 5. Okay, mu minus 5. So mu t greater than mu minus 5 and t greater than mu minus 10, right? So this is basically the common part starts from where? T greater than mu minus 10 is from here towards this path, and t greater than mu minus 5, this is from this part towards this. So which part is common between them? Definitely t greater than mu minus 5, right? So t greater than mu minus 5 is the common, so that would be what? T greater than mu minus 5, because in conditional probability the common part will be on the numerator, isn't it? Okay, so we need to have these two probabilities. Now consider the bell curve. Let's move on to the bell curve. Look, the shaded area, the yellow shaded area is 0.95, right? And we know that this shape is symmetrical. That means the area that you can see here and here, it is what? Same, right? So that means this area and that area will add up to how much? 0.05. That means here it is 0.025 and here it is 0.025 using symmetry, right? So what we can write is that probability of t, we can write here that probability of t less than or equal mu plus 10. It is how much? Look, the total area is 1. So from 1, if you subtract 0.025, what you will get? You will get this whole part, right? This whole part, isn't it? Right? Okay. So this is what? 1 minus 0.025. This is 0. How much? 0.975. Understand? So this probability is what? 0.975. So probability of t less than or equal what? Probability of t less than or equal mu plus 10. This is 0.975, right? And using symmetry we can say that also the probability of t greater than or equal mu minus 10, it's also the same, right? This is also what? 0.975, right? 1 minus 0.025. From 1, if you subtract this part, you will get what? 0.975. So what? Probability of t greater than mu minus 10, this is also what? 0.975. So we got the value for the denominator, isn't it? So we got the value for the denominator, that is 0.975. Okay, next is the numerator. For the numerator they wanted t greater than mu minus 5. That means we need to find out the value for the what? Mu. So we know that probability of t less than or equal mu plus 10. So probability of t less than or equal mu plus 10, this is 0.975. so standardize the value, mu plus 10 over 10 minus mu, I'm just standardizing the data, over sigma, this is equals 0.975. Fine. Now we need the inverse what? Normal. So you will get 10 over the sigma, this is 0.975, right? So for inverse normal, what would be the value corresponding to 0.975 area? We can get it also from the formula booklet. Okay, so you can get it, the percentage distribution. Okay, we need 0.275, right? Sorry, 0.025. yeah, 0.025 is this one, 1.96. okay, that means the standard value for this part, okay, the standard value for mu plus 10, it's basically what? 1.9600. okay, So this is 1.96, how much? 0 0 1.96 0 0. So what would be the value for sigma? Sigma would be 10 over 1.96. 10 over 1.96, that would give you 250 over 49. 250 over 49. So we got the value for mu, not the mu, it is the sigma, right? So we need to find out the probability of t greater than mu minus 5, right? So what would be the probability of t greater than mu minus 5? Let's find it out. So mu minus 5, probability of t greater than mu minus 5. We need to find out that probability. So standardize, that would be what? Mu cancels, so mu minus 5 minus mu over the sigma, right? Already we know the value for sigma, so mu cancels out. You can easily find out the probability, isn't it? Negative 5 over what? 250 over 49. So find out that probability. So that would be what? Negative 5 over 250 over 49. So that would give you negative 49 over 50. So we need the probability of z greater than or equal negative 49 over 50. Okay, so what would be the probability? So let's consider the probability, that is negative 49 over 50. We got the standard value for mu minus 5. So go to mode. If you are using class-wise calculator, Casio class-wise, then mode 7, normal cumulative distribution. So here we want to find out z greater than or equal. So the lower limit would be negative 49 over 50 and the upper limit would be infinite, 9999, something like that. You will get the probability, that is how much? 0. Take the exact value to get the correct answer. 83645 Okay, so we got the probability. Now just we need to put it in the fraction that we have just found, that is 0.836. It keeps going. Okay, so what would be the value? Okay, so 0.83645 over 0.975. Okay, so 0.836456911 over 0.975 would give you 0.857. 0.857. So the answer would be, the probability is basically what? 0.857, and it keeps going, so it can be rounded to 3 decimal places. That would give you 858. This is up to 3 decimal place, and that's the answer. Okay, so that was all about part C of question number 5 from S1 May 2024 paper, and that's the end of question number 5 of this paper. That's it.